And whenever we are building the portfolio, we'll have the W's, as you see here. And for instance, if we have 3 W's, we have W1, W2, and W3, and we have different constraints. So we have capital budget constraints, meaning that basically we start with 1, assume that we start with 100 money, and that will be basically equal to 1 in the weighted case. So for instance, this first one will take 30%, the second one will get 30%, and the last one will get 40%. So the sum of these should be basically 1, equal to 1 in terms of their fractions. And another constraint is long-only constraint. So in the market, we can go either long or short. Long means you buy the stock. So this is the traditional that you see in the market, buy the stock. So for instance, you see Apple, or like you see Bitcoin or Ethereum, and you basically buy the asset. In this case, I'm using the term stock, but this is for equities. So in general, it's buy the asset. And it means that long-only constraint means you can only buy the stock. So in another case, we can also short the stock. So meaning that we basically short sell the stock, sell a stock to another investor, which we don't have. This is called basically shorting. And this is happened through brokers. So we cannot sell a stock that we don't own, but through brokers, we can achieve such shorting mechanism. Whenever we are shorting, we can take the weight, can take minus values. So for instance, one example here is that for stock Apple, I'm just making up numbers. We can, in our portfolio, we can long 50%, and 50% of the portfolio, we are putting in Apple. So 70%, we are putting in the Microsoft. So this is more than basically 20% more than the one. And we'll also short in order to basically make these numbers 100%. So Tesla is minus 20%, meaning that basically 20% of our portfolio, we are shorting a Tesla stock. And in some cases, the portfolios can be made up of either long ones or the short constraints. But in some constraints, in some funds, due to the requirements, the portfolio can only be made up of long-only constraints. And another case is basically self-financing portfolio. So in self-financing portfolio, we assume that longs cover the shorts. And in this case, the result is basically 0. So for instance, we don't have any money. So by borrowing money, by shorting a 50%, assume that we for 50%, we short, in this case, Apple. And by the money that we get from the shorting, by shorting the stock, we get money. We long another stock, 50% Microsoft. So in this case, we make these long and short trades without putting any money. So we use the money we use for the shorting to buy the Microsoft. And again, we can have holding constraints. These are, again, all of them are, as you noticed, are simple linear constraints. So another constraint is holding constraint. For holding constraint, we have basically the lower bound and the upper bound. So for certain portfolio weights, we have the lower bound, meaning that we should hold at least L amount of certain stocks, and we can hold at most U amount of certain stocks, where in this case, L and U are lower and upper bounds on the asset positions. So these are holding constraints. Again, we can have different constraints. Another type of constraint is basically a leverage constraint. So in a leverage constraint, this is also related to the shorting. So if the portfolio is only long-only portfolio, then it means that we don't borrow any money and we are basically investing in what we have. But if we short the stock or short the asset, then we are borrowing the money and we are using a leverage. So for instance, if we have 50% Apple here, and in this case, we have, let's say 70% of Microsoft. and negative 20%, we have Tesla. So in this case, the total is 100 because our money is 100 and we use it. So we use 100, assume that we have $100 to start with. We use $120 to long only. By using the 20%, we borrow by shorting the stock. And in this case, leverage is 50%, 0.5 times 0.7 times 0.2. Even though it's short, it's also some amount. So the leverage is 1.4. So the portfolio is levered. So the more shorting we have, so here we only have 20% shorting, then the more leverage we'll have. So for instance, if we have 90% here and 40% here, it will be 1.8. So it's basically 1 plus 2 times shorting amount, where the shorting amount is basically positive. And in this case, the portfolio is set to be levered at 1.4. And cardinality constraint is another constraint. So assume that we have n assets. So in n assets, we want to select subset of them and we want to invest in only k of them. So for instance, we are using S&P 500 universe, which has 500 stocks, but we don't want to invest in all the stocks. Like we want to say, we want to invest only in 20 of them, 20 most liquid ones or the 20 highest market cap ones. This can be anything you want. And in this case, we add a cardinality constraint, and this cardinality constraint is basically tough. So directly, this is L0 norm. And once added, this basically makes the problem non-convex. So that's why in many cases, there are certain approximations used for these cardinality constraints. Another constraint is turnover constraints. The turnover constraint is basically the turnover of the portfolio. So in this case, we have this W0. And in this case, W0 assume is the initial portfolio. Like assume that we have A, B, C stocks. Let's say 0.4, 0.4, and 0.2. And in the next time step, we want to renew our portfolio. And we want to do is basically, we want to limit the turnover. So we can buy 0.3A, 0.3B, and 0.4 C. And in this case, turnover here is 0.2, 0.1, and 0.1. It's basically change in the weights and absolute value in the change in the weights, and it's equal to 0.4. And in this case, we can add linear constraints. So this is linear constraint, convex constraint, linear constraint to basically model the turnover, where we are basically limiting the turnover amount. And this is the turnover constraint. And the last one is market neutral constraint. So in market neutral constraint, we assume that the betas of the stocks are 0. So beta of a stock is basically, beta is defined as the parameter in the linear regression. So here are the returns of market. So we can take the returns of market in any way we want, and returns of asset. So we are basically calculating linear regression with respect to returns of asset with respect to the market. So for instance, if the market turned like this, the asset returned this. So for instance, daily, we are collecting the data for a year period. So this is how the beta is calculated. Then we are feeding a line. We are trying to feed a line, the optimal line by a least square equation. And basically slope of this line is beta. Slope is called beta, which shows the relation of the return of the asset with respect to the market. So positive beta means if the market is returning positive, then our stock is also historically returning positive. So if it's really high, then it means that, for instance, if the beta is something like 1.5, for instance, then it means if the market returns 10%, then expectedly our asset returns 15% historically. Again, this is obtained from the historical ones, and we can assume that the portfolio should be selected such that it will be market neutral, so that the portfolio money or the portfolio asset value will not be impacted by the market direction and the market movements. And that's been ensured by market, basically this market constraints. Okay, welcome back everyone. We were discussing about the constraints in the portfolio optimization. So again, there are many constraints. There can be many more. These are just the samples that we use, some of them in the practice. So the critical thing here is basically the leveraging and the shorting. So whenever we are shorting a stock, we are actually leveraging. And whenever we have the leverage, then the portfolio return, again, if we prove that, we can prove as in this case, that basically it's the new weights transpose times RT. So this doesn't change. So meaning that, for instance, if we have an A stock, B stock, and C stock, assume that A is 50% of this portfolio. So let me write here actually A, B, and C weight in the portfolio and return. So this is the weight in the portfolio and return of the stock. So if we assume a stock will lose its value, then we can short and then make a profit. So for instance, by longing, we assume that the stock's value will increase and we'll make a profit. So for instance, the value of A stock is 50%. Value is B stock is 70%. And C stock is negative 20%. And in this case, the return is basically 10%. 10% and 20%. So in this case, the return of the portfolio will be 10 times 0.5, 5 times 7 times minus 2 times 10, so it will be minus 2, and it will be minus 2 minus 4, and the result will be 8. So the portfolio will return 8%. So what we do here is when we are calculating the portfolio return, when we have the leverage, we are actually multiplying the short amount, the weight, with the return as well. And this has been proven here. So assume that we have an B portfolio weight and without the leverage, and with the leverage, it becomes B times L. And again, by using these equations, returns, we put into the equation and we formulate and we derived the fact that portfolio weight times return will again be basically the return of the portfolio.